So if you're thinking about building your own home and acting as your own general contractor, then trying to figure out the actual steps that go to get everything started and what to do might seem like a lot. This will even help you if you're using a general contractor, so you can understand the process a bit better. In this video, I'll share exactly what happens before I ever set foot on a job site. Now, I'm usually sitting at a desk looking at a grading plan, and that plan, drawn by a licensed civil engineer, is the document that drives everything I'm going to do on that site, from the first pass of the machine to the final check before I walk off the job site. Hi, I'm Mark with AccuDirt, and today I want you to understand exactly how I plan a house pad from scratch, starting with the engineered drawings through the final site visit and all the way through finished grade before a single blade hits the dirt. Let's start with the building, or with the grading plan, because this is where the job actually begins. A grading plan is a document produced by a civil engineer, excuse me, typically hired by the owner or the builder, that tells me exactly what the finished site needs to look like. It shows the pad elevation, the dimensions, the finished floor elevation, the drainage slopes, the swale locations, where cut and fill is happening across the lot, and the grades that need to be achieved at specific points on the site. It may also reference the soils report and specify the compaction requirements. When I get a grading plan to bid, the first thing I do is read it carefully. I'm looking at the finished floor elevations. That's my primary target. Everything gets built to the top of the slab at that number. I'm looking at how much cut and fill is involved, because that tells me how much material's moving and in which direction. I'm looking at the drainage design, where water's intended to flow, where the swales are, and what the specified slopes are across the site. I'm looking for anything that the plan might be complicated by the site conditions, like tight access, significant elevation changes, proximity to property lines, utility lines. By the time I've read the plan thoroughly, I have a picture in my head what that job actually looks like finished. Then I go to the site to verify that picture against reality, what's there. This is an important distinction. The site visit isn't about figuring out what to do. The civil engineer has already figured that out. The site visit is about identifying anything on the ground that the plan needs to be reconciled with. And there is almost always something. When I walk the lot, I'm reading the existing conditions against what the plan actually shows. Is the existing topography roughly what the plan assumed? Are there any obvious soil issues like caliche at the surface, or signs of previous fill dirt? Any drainage problems the plan might not have accounted for? What's the access situation for equipment? Can I get in and out the way the plan assumes, or is there something in the way? Are there any utilities, trees, or existing improvements or damages that might affect how I'm going to work the site? Now, sometimes the site matches the plan almost exactly and the visit is quick. Sometimes I find conditions that need a conversation with the engineer or the owner before work actually starts. A drainage situation that doesn't match what was drawn, soil conditions that might affect the compaction, the specs, an access constraint that changes how I sequence the work. That conversation happens before the dirt moves, not after. Once I've walked the site and I'm happy that I understand both the plan and the existing conditions, I'm ready to start the job. The first thing I establish on site is my benchmark. The grading plan gives me a finished floor elevation, a specific number reference to a datum, usually a mean sea level or a local benchmark established by the engineer. That's not something I guess, it's already established. My job is to translate that number into a physical point on the ground that I can reference throughout the entire job. I set a rotary laser level on a stable tripod. It self-levels, and from that point, every elevation measured I take on the site is referenced back to that laser plane. Using a grade rod or 3D equipment, a graduated measuring stick with a receiver on it, I can read the difference between the laser beam and any point on the ground. That difference compared against my target elevations from the plan actually tells me whether I'm cutting or filling at any given location and by how much. Cut means the existing ground is above my target subgrade and material needs to come out or be cut out. Fill means the existing ground is below my target and materials need to come in and be laid in there to get to that elevation. The plan tells me where each condition exists. The laser verifies it on the ground. Before dirt moves, the engineer or surveyor will have been out to lay out the pad, setting physical stakes on the lot that translate the plan dimensions onto points on the ground. Corners get staked, the perimeter gets staked. The survey is done before my equipment shows up. And those stakes are what I'm working from. Now, occasionally I'll do basic layout myself on simpler jobs, but on permitted residential or commercial pads, that layout is typically done by a licensed surveyor working from the engineered drawings. So it's their stamp on where the work happens. And it's a very important part of the process that protects everyone, the owner, the engineer, and me. My job is to execute the earthwork to those stakes and to the elevations on the plans. That's where my work begins. Now the earthwork can start, basically. If I'm cutting, I'm removing material down to the subgrade elevation specified on the plan. Subgrade is not finished grade, it's the elevation below the finished pad surface that accounts for the compacted fill or any base material, and the concrete slab above it. I'm cutting to the number that, after everything above it is built correctly, puts the top of the slab at the finished floor elevation on the plan. I hope that makes sense. If I'm filling, I'm placing materials in lifts, typically 6 to 8 inches of loose material at a time, often adding moisture to the dirt and compacting it each lift before the next one goes down. This is not negotiable, and it's not a shortcut you can take. If you do, there are consequences. Dumping several feet of fill and compacting the top does not compact the material in the middle. That material stays loose, and you've built a pad on an unstable base. It will move. So each lift gets compacted precisely and then verified by a certified compaction tech before the next lift goes down. That tech is testing the density specs in the soils report, the number the engineer determined is required for this soil type to this site to support the load above it. Those test results get documented. That documentation is part of the permanent record of that job. When I'm at subgrade, I check my elevations across the entire pad footprint with a laser. I'm looking for consistency, no high spots, no low spots, nothing that's going to cause problems, often when the concrete goes down. This check catches mistakes before they get buried under the next layer of work. It's really important. Then the finish grade. Finish grade is the final pass, getting the top of the compacted fill to the exact elevation slope specified on the grading plan. This plan will show the finished surface slopes, typically a slight grade away from the building perimeter to direct surface water away from the foundation. These slopes are designed by the engineer. My job is to achieve them accurately in the field. I use the laser for the finish grade the same way I use it throughout the entire job, checking elevations at grid points throughout the property or across the pad, or with laser automation built into the equipment, making adjustments, checking again. This is detail work and it takes time. The grading plan has specific numbers at specific locations. I'm hitting those numbers. When finish grade is done, I walk the pad. I check the corners against the survey stakes. I verify drainage slopes, make sure they match the plan. I look for anything that doesn't look right. If something's off, I address it before I call it done. The compaction testing firm does the final verification. The pad gets signed off, and that documentation goes in the project file along with the soils report and the grading plan itself. The concrete contractor gets a pad that was built to an engineered spec, verified by testing, and documented from start to finish. That's the job. The civil engineer designed it, the surveyor staked it, I built it to that design, and every step of that process is on paper. If you're an owner builder or a builder in the Scottsdale or Phoenix or Rio Verde area, and you want to talk through the site prep process on your project, reach out to me below at AccuDirt.com or find the number in the description. I'm more than happy to review a grading plan with you and talk through what work actually involves. If any of this raised any questions about your specific project or an upcoming project, that's exactly the conversation I want to have. Feel free to reach out and let's talk. If you're thinking about building your own home and acting as your own general contractor, then trying to figure out the actual steps to get everything started and what to do next might seem a little confusing or daunting. That may have been a lot. I thought I might share it just so you can understand what happens. So if you have any questions, reach out. We'll talk further. I'll talk to you soon.